Good morning, students. You guys should be watching this video on Friday. It's going to be very short. Just to recap, yesterday we watched the video on the first page and you took notes. That was a 15-minute long video. Go back and watch it if you haven't or if you were absent. Then I gave you like a short 7-minute video to show you how to solve number 1 and number 3. You are responsible for doing front and back of this page, which is 1 through 8. And then today we are on Friday. So Friday, you're gonna need some colored pencils. I don't have colored pencils, so I'm gonna go ahead and use red, blue, okay, and then of course black. Okay, it says exponential functions are ones in which the variable is in the exponent. As with other types of functions, there is a parent graph for exponential functions where b is the base, and we can create other similarly shaped graphs using transformations. Complete the table of ordered pairs below for each of the following parent graphs. So this is a parent base 2, this is a parent base 3, and this is a parent base 4. Then use the points to sketch each graph on the coordinate plane below and the given colors. Okay, so you're going to go to your calculator. I'm going to look up Desmos since I don't have my calculator with me. You can use your phone or the calculator at school. And I'm going to graph 2 to the x. When I look at my table, 2 to the x, when x is equal to -2, y is equal to 0.25. When x is equal to -1, y is equal to 0.5, and so on. So I'm going to take my table and copy it onto my sheet of paper. Okay, then you're going to do the same thing for 3 to the x and 4 to the x. I went ahead and graphed 3 to the power of x, and these are my table of values. Go ahead and copy that down. After you graph 3 to the power of x and copy down the table, you're going to go ahead and do the last one, which is 4 to the power of x. And there's your x values and your y values. You're going to go ahead and copy that into your table. Okay, now you have your table for 2 to the power of x, 3 to the power of x, and 4 to the power of x. I want you to plot each of these points. We've got to be real careful since they're not exact. Okay, so I'm going to go ahead and plot -2.0625. So it's going to be a little bit like right here, the -1 and 0.25. Maybe about here, 0, 1, 1, 4, 2, 16, and I ran out of space. And you're going to connect the dots. It's like super close to the y-axis, and then it begins to grow like really quickly. Okay, that's the blue one, which I'm going to highlight in yellow. Okay, and then you're going to do it again for 3 to the power of x. So 3 to the power of x is -2, 0.11. So like super close as well. A little bit above. Almost the same, I guess. -1, 0.333. A little bit more than 0.25. 1, 1. 2, 3. 3, 9. So we ran out of space there. It'll be something super close to the y-axis. Barely passing through here, goes through the y-axis at 1, and then it's increasing like that. Okay, this should be in red. Okay, and then finally you're going to graph your last one, which is 2 to the power of x. So at -2, it's at 0.25, so a little bit higher than the previous points. 0.5 at -1, 0, 1. Remember that all your exponential functions always pass through 0, 1. Okay, and then 0, 1, 2, no, 1, 2, 3, 4, sorry, mix up here. 3, 8, which we don't have space for. 2, 4, it's right about here. 1, 1. I just need to double check, okay? So I have 2, 4, 1, 2, 0, 1. Okay, we're good. Then, of course, real close to the y-axis, goes a little bit higher than the other ones, passes through 0, 1, hits 1, 2. It looks something like that. Oops. Okay, and it says find the domain and range for each parent graph. So what would be the domain and range for the black one? It's always going to be negative infinity to positive infinity, or all real numbers. Those are 3 different ways to write the same thing. And then the range for 2 to the power of x is from 0 to positive infinity. Or you could say for all y values that are greater than 0. Or you could say for all y values that are between 0 and positive infinity. 3 different ways of writing the same thing. The horizontal asymptote is at y equals to 0 for each of them. If you notice, they get really, really close to the y-axis, which is where y is equal to 0. They get really, really close to the y-axis, but they never pass it, so this is your horizontal asymptote. Okay, turn to the back. And you're going to repeat the same steps for each of these, okay? So they give you 2 to the power of x, and they want you to graph 2 to the power of x plus 2, 2 to the power of x minus 2, and see how that changes your domain, your range, and your asymptotes. Your domain is not changed, but your range is, and it's based on the asymptotes. Okay, you are responsible for finishing all of the examples. There are 1, 2, 3, 4, 5, and then the recap is 6. So you're responsible for all 6 problems. If you don't finish today in class, then that is your homework. Hope you guys have a good weekend. Bye.